tried to make MMOs like WoW for 10 years. People tried for 10 years.
Free cereal. You gotta get it.
Free cereal?
Yeah, in the little lounge over there.
Oh, cool.
It's a lounge.
Would you lounge in it?
The nerd cave or the
Yeah,
Oh, okay.
Cheez-It cereal. Yeah, ever since they put it in the fridge, every time I milk.
And it was cinnamon
Cool.
toast crunch.
Wait,
So
so
it's like,
they have public milk?
yeah,
Yeah, public milk.
all the milk that's in there is public.
That's how you
static
would.
milk.
Dang.
And the milk doesn't change.
Yeah.
Community milk?
So if you use the milk, it's the same milk that
Nice.
somebody of human class would also use.
Yeah.
Yeah.
All right. So so let's talk about the final exam. Hopefully, no big surprises here, right? I'm not trying to trip anybody up. I'm not trying to like find the one thing that you didn't think to study and give you like 50 questions on that, right? So this should be pretty straightforward, but you can expect to probably spend hour and 50 minutes, right, or something close to that, depending on how quickly you work. So,
Can it fly?
what?
Can it fly?
Can it fly? Yeah.
Is it hard?
So, hour and 50 minutes, Monday, 12 o'clock is the official time, 10 o'clock is also an option. 4 double-sided pages of notes, or 8 single-sided if you like. And kinds of things you should be prepared to do. So there will be a section of short answer, fill in the blank, matching, true, false kind of things. That's either 20 or 30 points. I don't remember how I set it up, but a section of the test will be short answer. And then the rest will basically be programs and programming. So kinds of things to expect with programming. Write a snippet of code to do blah, right? So you've seen these before. Or here's a section of code, modify it to make the following changes. Or here's a section of code, look at it, analyze it, and answer these questions about it. Okay, so those kinds of things. And as usual, if I want a snippet of code, you can just write the snippet of code. If I want a main method, it should start with public static void main. If I want a class, it should start with class name, curly bracket, and end with a curly bracket, right? So depending on what I ask for, you may need to write 2 lines of Java, or you may need to write a whole class definition, or something in between. All right, so topics. So some of this is from the midterm review. Writing code, analyzing code, answering questions about code. That's what we just said. The idea of an object-oriented language, we don't really need to worry about it being interpreted versus compiled, but I put it up there anyway. But Java is interpreted, right? So you compile into this intermediate language called bytecode, and the virtual machine, which runs when you say Java class name, interprets what's in the class file. Right, but it's not compiling it down into the binary code the way C gets compiled, for example. Object-oriented approach to managing code and data, basically bundling code and data into a single object, right? So that we have data, but we also have methods or functions or code that's usually designed to interact with that data. The idea of information hiding, so we can use private to take certain aspects of our class and keep them hidden from view from whoever is using this class. And our code has access to those variables and can manipulate them and interrogate them, but we're deliberately keeping outside code from working with that level of our objects, right, our class. And that ties into the idea of abstract data types. So if you're implementing a stack, you can do this with a linked list, you can do this with an array. If you do it with an array, you can start from element 0 and grow towards 1,000, or you can start with element 1,000 and grow towards 0. And in one case, you'll increment your stack pointer for a push, and in another, you'll decrement. If you have a linked list, you have no stack pointer, right? You just keep inserting at the beginning of the list, and that's always the top of your stack. So whatever it is that you're doing to implement your stack, you don't want a variable called stack pointer that the user has access to. So if you were using a stack pointer, you would make that private. If you've got a handle to your linked list, you would make that private. And the user's interface to your code is push, pop, is full, is empty, maybe peek to see what's on the top of the stack, and that's it. So that's looking at a stack as an abstract data type. okay, as opposed to a stack is an array of numbers starting from location 0 with a stack pointer that points to the last number you pushed. That's an implementation. So ADTs, right, and we've just kind of been talking about that through 222 and through this course. You should definitely know general Java syntax, ifs, fors, whiles, declaring variables, assigning values, and so on. If there's something that I think you probably should have written, 100 times by now, and you write it wrong, I might dock you a point. But I'm not going to try to be, the syntax checker, because we have compilers for that. So try catch block if you put exception E inside curly brackets instead of parentheses, right? I'll mark it on your test, but I won't take off points for that. Because that's stuff that the editor or the compiler will tell us how to do, right? But if you're trying to define a class and you don't use the keyword class, right, or you use some random keyword like class def or something like that, right, I'll probably take off a few points. So know the basic syntax, and if you've been writing your code all this time, right, you probably know by heart the basics. Creating an instance of a class, right, so that's the new keyword, so we've done that. Accessing variables and methods from an object, so that's object name, period, and then the name of the method or variable, so you know all of this stuff, right? Private versus public. Method signatures, right? So signature is what? It's the types of arguments and it's the name of the method, right? So if you have two things that differ in some aspect of that, they have different signatures, they're different methods. Static versus non-static. So we didn't talk about this as much as we might have, but generally, when you're writing code, public static void main is about your only static, right? Unless you really have a method that you don't want to refer to a particular instance of your class. For example, a square root function, right? So that can be a static. Most other things are non-static. And know about this keyword, right? So this refers to me. And mostly we use it in something like a constructor where we want to refer to a variable that's part of the class, but we have a local variable with the same name. So we can say this dot variable and refers to the class variable. Yeah?
If I'm understanding this correctly, like when you say something dot this, isn't it true that you never have to say that? That's just for our clarification.
You mean this dot something?
Yeah, like in a constructor or something.
In a constructor, you don't have to say that.
Because it would just know that the right side is what's being passed in, and the left side is local.
Well, no. So so here's the constructor. Here's our class, and it's got a height and width. Right? So I want to take this argument and I want to save it here in this class variable. My hand's big. I want to take this argument and save it in the class variable, right? I can't do this.
It won't automatically
know
what you mean?
I don't believe so.
Oh, okay.
Right? So this dot h. But the other way to do this is, h2, w2, and then h equals h2, w equals w2. And that's fine, except we shouldn't be calling our variables w and w2 and h anyway, right? It should be like rectangle height, rectangle width. And so it might make sense to say this dot rectangle height equals height, or rectangle height, and so on. But you can get around it like this. But there are other times that you need the word this. For example, so a common example is when you're constructing a thread, you are creating the thread, so you know how to get to that thread, right? Because you created it, you can save that variable somewhere in your memory, but the thread has no idea who created it, right? So if the thread wants to talk to you, it's got no way to get to you. So when you construct it, you can pass it this, which is you, and it can save that and say, Jesse's class space save, and it can say save equals the argument, right? And now it can get to the object that constructed it by just using that saved, right? So that's one way to use this. that's not really, there's no other way really around that. All right, data structures, that's the name of the course, right? Advanced data structures. So arrays, and we're pretty comfortable with arrays at this point, but remember arrays in Java are a little different. So we declare an array with something like right, integer bracket bracket my array. That's an array of integers. Or let's go with recs. Right, so that's an array of recs, and then construct 100 rectangles. Right, but those rectangles don't actually exist. Right, so there's declaring the array, there's setting up the space for effectively 100 pointers, right, 100 slots to hold your rectangles, and then there's actually constructing the individual rectangles. So it's just that sort of three-step. There we go. All right, so arrays, lists, right? Linked lists, singly linked lists, doubly linked lists, circular lists. We know all of these structures. These things are also built in inside Java, right? There's list arrays and other things like that. And I'm not going to hold you responsible for the details of those, but you should know that they exist, and you should know the basic concepts of them, right? And so play around with those if you like. But pretty certainly, if I ask you questions about linked lists, it's going to be linked lists that you're writing in Java, okay, which is what we've been doing here. Same with trees and hashes and things like that. So lists, trees, recursive algorithms, right? So we used recursion a lot when we did decision trees, and when we talked about trees in Java, and we looked at traversal and search and insert, right? Those were recursive.
Will we be tested on red-black trees?
Maybe concepts, okay, but not code and not details of the algorithm. But basic concept of red-black tree, it's an attempt to keep a tree reasonably balanced by constraining how imbalanced the heights of the subtrees can be.
Have you ever used a red-black tree?
Indirectly, sure. So if you use a tree map in Java, that's a red-black tree underneath.
Oh, okay.
But I've never coded one up, so I don't think I've ever coded an AVL tree either. But I've coded more binary trees than I can imagine, and linked lists. So AVL trees are balanced trees, but they're perfectly balanced in the usual notion, right? The recursive definition of balance. And in both cases, right, the key to keeping this thing balanced, according to whatever notion of balance we have, is to check the balance after you do an insert or a delete, and then make adjustments at that point as necessary. And the adjustments are usually a series of rotations of some sort, or moving around nodes in the case of a red-black. So you are not responsible for knowing the details of balancing an AVL tree. Okay, just the concepts of what they are and what they do. But I'm not going to give you a tree and say, here, insert something, and now rebalance it, and do a left-right rotation or stuff like that. Because we didn't really do that much with it, right? And it's an algorithm. So recursion, generics. We didn't get around to creating generics in here, so don't worry about that. But you should know how to use generics, right? Anytime you use a list array or a tree map or a hash map or anything like that, you're dealing with generics. So you got to specify the type in angle brackets, basically. And then it just goes from there. You should know about iterators, right? What's the classic example of an iterator? kind of, that's definitely iteration.
So for like the classic little, you know, for loop iterator.
Think about scanners. Yeah, so has next and next is an iterator model. So if you construct an iterator on a linked list, you can say, well, iterator has next, and then you can say next, and it gives you the next element from your linked list. And you can keep iterating over that as long as has next is true, and every time that you say next, it'll give you the next element from your structure. And this is important when you have something like a hash table where there's no inherent first, second, third element, right? With a linked list, we can start at the head, we can give me the first, second, third element, but something like a hash, there's no natural ordering. So we use an iterator to say, you know, is there something else that I haven't seen yet? If so, give it to me. And when has next is false, we know we've seen all the data. So that's
Didn't hash have like a way that you could like get your first key or something like that?
that's the iterator.
Oh, okay.
Yeah, so get first key is basically how you initialize it, and then next key
Oh.
gives you another key, and then there's like a has next key or something. So, and it's a common structure, and it's basically what we're doing when we read from a scanner, or, you know, from a file of some sort. We say, is there something else, and if there is, give it to me. So has next line is the same structure, different implementation area. All right, make sure you know how to use strings. Okay, so length equals compare to toString, character at, I didn't put on there, but that was on the midterm, right? So basic things. And make sure you understand toString, right? That's how you get an object to print nicely if you say print line or you try to concatenate, right? So if R is a rectangle, and I do this, right, it's going to try to concatenate R equals sign to R. To do that, this has to be a string, but it's not a string, it's a rectangle. So how will it decide what string to treat this as? It'll call the toString method, right? So toString doesn't print anything, usually it could, but rectangles toString, a double's toString, all these things, they don't print anything, they return a string so that we can concatenate them as if they were a string. Why and when we don't use double equal sign for comparing objects, right? So S1 equal S2 doesn't tell you if they have the same characters. It tells you if they're the same object, right? So equal is telling whether objects are identical, not whether the contents of that object's data is the same. So that's why we have things like dot equals. So defining arrays, setting the length, arrays of objects, initializing the array versus the object. We just talked about that a minute ago. Scanners, print writer, system.in, and file. This is pretty much all we've done for input and output. There's a lot more, and some of you explored that in PA5 in particular. So there's buffered streams, there's raw streams, there's data input and data output streams, but these are the basic scanner input, print writer, output. Yeah.
I was just gonna ask if there's like gonna be like swing questions, like action listener, like stuff.
Yeah,
like that.
I have that on here in a little bit, but yeah. So swing. I'm not going to ask you to, you know, write a mouse listener or construct a J-frame and stick a panel inside, right? These things get done for us by Window Builder or whatever else we're using. But once you've got a mouse listener that Window Builder made for you, and you want to do something like figure out what the XY coordinates are, you should be able to do that, right? So it passes you an argument, it's like a mouse event or something, you should at least know that there is a way to use that object you're passed to get, say, x and y coordinates. Okay. Now if you say get x with a lowercase x instead of an uppercase x, or you say dot x location parentheses instead of get x, right? I'm not worried about that. That's just syntax. But you should understand that this mouse listener is called and it's passed an object that gives you information about the event. So from that object you can get coordinates. You can find out what button was pressed. You can find out if the control key was held while the button was pressed, and so on. So again, the kinds of things that you've had to do to make GUIs, to do tic-tac-toe or whatever else you've done with a GUI, those things I want you to understand. If you want to draw a circle, right, you have to do that in the paint method, and you use the graphics object that's passed to the paint method. Typically we call it G, and G has a method available for drawing a circle. Now if you say G.drawCircle, I'm not going to take off points, right, because it's really draw oval, but that's just syntax, right? But if you don't know that there's a graphics object being passed to paint, or you don't know that that object has methods available for doing the painting, or you don't know that you need to do that painting inside the graphics, the paint method, right? That's stuff I'm going to be testing for. So again, stuff that you've done and dealt with and worked through. We can't call paint, but we can call repaint. And repaint says call paint for me. So stuff like that. So scanners are mainly for input. We can construct on system.in, or we can construct on a new file, right? So we can say new file, put in a path name to a file, and use that in the constructor of a scanner. Print writers, we don't need to make a print writer for system out because we have a system.out.println. But we could do a print writer on a new file and then say whatever that print writer is .println. So that gets us in and out, and we use that mostly. Most people use that for sockets. And same idea, construct a scanner or print writer using the socket.
Couldn't you create a print writer for system out and then it's just less typing?
I think so, yeah. But you can also...
Syso, enter.
Yeah, but I was going to say you could also write your own method, like
That's true.
P takes a string and it just calls system out println.
That'd be way better.
Yeah. I wonder how many people have done that.
Because system.out, print, that's just too much.
Yeah, it was kind of an initial turn-off for me when I got the job. I'm like, what? But
Yeah, on
fortunately it
Facebook,
wasn't a trend.
on Facebook, I'm in this programming group, and people were saying like type hello in your favorite language or whatever, and then I'm seeing all these easy ones, and then I see system, that, and it's
Yeah,
just like,
yeah.
geez, that sticks out like a sore thumb.
Yeah,
Even C++ looks is easier or
Mhm.
less,
yeah.
characters.
Well, and then there's assembly language. So.
I didn't see any of that.
How hard is
Just
that?
type in binary.
Yeah, yeah.
Type it in binary. Everybody
Totally.
will be like, what?
Yeah. So class extensions, and we haven't done a whole lot with those explicitly, but we've been using them in everything we've done, right? Everything except an object is an extension. But we've used them mainly for swing, right? We extend J-frames, or we use them with threads. We extend the thread class. So class new extends old, right? And new basically is a copy of old, but you can modify pieces of it. So you can add new methods, you can change existing methods. And if you change an existing method and you want to get to the old one, you can say super dot. And super refers to the old class in this case that you extended. Exceptions and exception handling, try catch block. So let me make a general comment here. Something that I saw repeatedly. So try, and there's some good stuff you want to do. Catch whatever type of exception you want in some sort of parameter. Print an error, catch fire. etc.
Burn the code.
It's the HDF instruction, halt and catch fire. You put in assembly language code. So what's going on here? You're trying to open a socket connection, okay? And there's a possibility that you'll get connection refused, okay? But you're hoping that it will open the connection successfully. It'll come out of the try block, and then you want to say send stuff through the socket. So this is open socket. You gotta think a little carefully about what happens if we end up in this catch block. When we came down here, we did not open the socket. So we're gonna print an error message, and we're gonna generate the little electric spike into the seat of the chair to like remind the user. Do we wanna fall down and then go ahead and start sending stuff through the socket? Probably not, right? So more often than not, at the end of this, you're gonna wanna do something so that you don't just continue with normal processing. And I saw that missing in a lot of people's code. And it was usually in a case where you weren't going to get an exception, but Eclipse was forcing you to put in a try-catch block, right? But if something goes wrong, if you try to connect to a port and that port's already in use, and you end up in the catch block, ask yourself, what should we do in this case, right? Even though it gives you a nice little set of code there to print a stack trace, what else do we want to do? Does it make sense to just print an error message and then continue as if everything was fine? Usually the answer is no. Now sometimes it'll be okay. Sometimes you want to do something, if it doesn't work, I don't care, we can still keep running anyway. But that's kind of the exception. So think about what do you want to do in this catch block, and a lot of times what you want to do is return. Is that a question? Or? Okay.
I learned about system.exit from the...
Oh yeah. So system.exit is nice, right? System.exit parentheses, put in a value, and it'll kick out your whole JVM at that point, which you may or may not want to do, right? If you do it from a thread, I think it still exits the whole program. Is that correct?
I think so.
Did you try that? Yeah, I'm pretty sure.
Because I looked it up, especially with the error I was dealing with, like the one that we saw when I was presenting.
Mm-hmm.
I think in the documentation it says any non-zero is an error, but if you, for whatever reason, want to just close the program and it's done it's done for the reasons that you want it to be done for, then you just pop in a zero and it'll just close things up.
And I'm pretty sure, and there might be a 256 multiplication here, but if you system.exit some number and then you echo $? From the shell, it should be the number that you exited with. So it's a way to pass back a success code, basically. Just like in the shell, you can say exit such and such, or in C, you can say return such and such.
Shouldn't there be a way to restart the program automatically if the exit code less than 0 using a bash script or something?
Yeah. So you can run your Java program and check $? And if it's not 0, go back and run it again or something. Swings and GUI, so definitely be able to work with the paint method. So public void paint graphics G, and we already talked about event handlers, mouse listeners, button listeners. All right, yeah.
And repaint goes in paint?
Repaint can go anywhere, takes no arguments, and it asks that paint be called. But you probably wouldn't want to repaint from inside paint because it would loop forever. Right, every time that it paints, it would be saying, hey, and when you're done, you get a chance, call paint. And so it's just going to continually call paint. But technically, I don't think it's wrong.
So you would put repaint in something like code happened, update this flag, and then repaint.
Exactly, yeah. Tic-tac-toe, somebody moved, we've got a new entry in our array of positions, call repaint, so we see the board with this new X in this position.
Okay.
That's exactly right. Yeah.
What was the situation where we needed to call superpaint again?
Oh, anytime that you're so you're basically overriding the paint method. right? So there's a default paint method which draws the frame and the X button in the corner and so on. But if you want to do painting inside, say, a JPanel, you're making your own version of paint. But if the only thing your paint method does is draw a tic-tac-toe board, it's not necessarily going to draw the frame on the outside and the X button to close and the title and all that stuff. So in the beginning of your paint, you call super.paint, pass it the G argument, the graphics argument, and that does all the stuff that you'd like paint to do, and then you just go ahead and define some other stuff. Yeah. So threads, so extending the thread class, and some people used implements runnable, and that's fine, and there's reasons for doing one versus the other, but I want you to know how to extend the thread class. Okay, that's what I'm going to be looking for. So double check on that or ask me about it. And once you extend the thread class, right, there is a start method available to you. There's also a run method. The run method doesn't do much. So you typically override the run method by writing your own. And if you call run, it's just a method. But if you call start, it creates a new thread, and then it calls the run method. So you put the code that you want to have executed in a new thread inside run, and then you call the start method, and that creates a thread, executes the run code. When run exits, the thread dies. Yeah.
I was curious, because in, I think it was 224, you, some of us got used to in 121 using scanf, or no, just scanf.
Scanf, yeah.
And just doing the whole all-in-one input reading, and then when we got to 224, you were like, there's issues to that, so we're going to try to keep reading and parsing separate.
Right.
Are there any serious concerns with using extends thread or running implements runnable?
Implements runnable? Along those lines, no.
Okay. So is it kind of just like preference, like on a...
Implements is a different kind of beast, right? And we haven't really talked about it. It's tied into, I believe, interfaces, where you can say, here's a blueprint for a class, right? These are the kinds of methods it needs. But I'm not going to give you any methods by default, okay? But it needs to implement this and this, right? And so you implement that interface and you go ahead and you write some methods for it. There's no practical difference for what we've been doing, okay? All right. Yeah, go ahead.
Yeah, we kind of looked up what the difference was we were trying to get Pt5 to work, and it seemed like if you're going to be overriding like functions that would have come in thread, that's when you would use one.
I think it also helps if you want to have something that extends another class but also implements threads, so that you don't have to extend the rectangle class and then extend a thread.
Yeah, that was something I saw where people said they wanted to, yeah, exactly that, like extend another class but still have it be a thread.
Right, right.
And you can't extend two things at once.
Yeah, I mean, you could make one that's an extension and then extend that or something, but... You had your hand up here?
Oh,
Okay, cool. All right, synchronize. We talked about that a little with Yoda and Darth Vader, right? So anytime you have multiple threads, and we've mostly been able to ignore this, but anytime you have multiple threads, you have a danger of data corruption, deadlock, live lock, things like this, depending on how these threads interact with common shared resources. So mostly it's an issue if you have two or more threads trying to write the same variable, right? And once that happens, potentially you get into things like, you know, the corruption of data we saw with the voting program. And if you're trying to read and write and synchronize with one another, right, you can get into these deadlock states where you're waiting for a resource someone else has and they're doing the same. So synchronize lets us basically say, hey, this variable or this section of code can be accessed only exclusively. So you ask to synchronize it and you'll either block or you'll be given access and nobody else will be allowed access until you're done with that section of code.
You put that in both the thread and
Yeah.
both threads?
Because if you try to access a variable without saying synchronize, it's not going to stop you.
And you just throw an N in the parentheses.
Yeah. Throw what in?
When we were doing synchronize, we threw an N in the parentheses.
N.
A letter N. It was like we threw something random in the parentheses.
So when you're synchronizing a block, you have to put in an object that you're going to use basically as your semaphore, as your flag. And it doesn't really matter what it is, as long as every piece of code that's trying to synchronize with each other uses the same object. And you can do this by hand, right, by just setting a flag saying I want exclusive accents. The problem is you can't synchronize that flag setting, right? You got to have some lower level mechanism to make sure you don't both try to set the flag at the same time.
Oh, I see. N is an object that you created an empty class.
Yeah, yeah.
Okay.
All right, and then sockets. So, and this is fresh in your minds, I'm sure. So in Java, it's mainly the socket and the server socket. Server socket binds a port, and usually you say accept, which means wait for connections. And if you create a socket, you can identify it with a machine and a port, so an IP and a port number. And if there's something listening to that port on that machine and trying to accept, it'll go ahead and accept, and your socket gets created, and now it's connected to a socket on the server side. And get input stream, get output stream let you access the two input and output mechanisms that you can use, for example, with a scanner and a print writer, or with other things, so you can read from and write to the socket. Yeah?
I found it really good. When you said binding, I didn't really understand when I was writing Pt2, but now I'm kind of like getting where my confusion was.
Mm-hmm.
When I was trying to research more about doing Pt2, I found a really good flowchart from IBM actually.
Okay.
On, like creating sockets, binding them, and then like
Okay.
all the major things you need to do with server and clients, regardless of what you're trying to do.
Cool, cool. You want to post a link on the discussion?
Yeah.
That would be
I'll see if I
cool.
can refine that.
This is one of the things about working with something like Java, right? It does so much for you that it really kind of hides a lot of details that might be worth knowing. So if you try to do sockets in C, it's a much more manually intensive process, right? You have to create the data structure sort of byte by byte, cobble them together, put them in the right places, and you create a socket and you attach it to a port, and you say listen for connections, and then when you get a connection request you can say accept, right? And you sort of have to do each of these things one step at a time. In Java you just say here's a server socket, accept a connection, and bang, you've got a socket, right? So what you're describing in this figure probably matches closer to what you do if you were doing this, say, in C, right, or assembly language, where you've got to actually do each of these pieces. It's nice not to have to do that, right, but it's also nice to sort of know what is going on at that level. So, but you'll do networking at a university and you'll get into deeper levels of all of that, most likely. That's pretty much 223. Yeah. So, nice work. Congratulations on surviving. Because making it to the end is an accomplishment in itself. But I really enjoyed this class. Class of students, right, throughout 224, 2 and 3, plus some of you I had in courses last year also. So thank you for your energy and attention and efforts and contributions, and it's been really cool for me. I think you're in good shape as you go on from Clark, so that's exciting. So I will let you out 2 minutes early since it's our last class.
Thank you.
All right.
Would you say we're programmers now?
I would say you're programmers now, absolutely.
Great. Yay.
Yay.
Did you just snap your finger?
I did.
No, I
That
would
was-
never do
that was 100%
anything.
just-
Come on,
that was
snap
just
of a
pure
finger.
success.